Visual Studio is an integrated development environment, or IDE, that allows programmers to write, compile, and link their programs within one unified interface. It is organized in a hierarchical structure. At the top level are solutions. Solutions consist of a set of related projects. Each project results in an executable program. Within the project are source files, the various individual modules of code that are compiled together to create an executable. A solution must have at least one source file. High-level programming languages like C and C++ are independent of the hardware and have to be translated to machine code in order to be executed. This process involves compiling and linking. Visual Studio takes care of this process for us, as we will see when we build our executable program. Let's create a new solution. Go to File, New, Project. By default, this process will automatically create a new solution as well. Go to Visual C++, then select Win32. The project we want to create is Win32 Console Application. This template is for a C or C++ program for Windows, and no additional libraries beyond the ones enabling standard text operations will be added. You can give the project a name at the bottom of the dialog. You can also name the solution and choose a location for the project. Checking Create Directory for Solution will put all the project files in their own folder, separate from the solution file. Click OK, then Next. Select Empty Project in the Application Settings dialog, then click Finish. The project is now set up. All we need to do is create a source file. In the Solution Explorer, right-click either the Source Files folder or the project itself and go Add New Item. Select C++ Source and give it a name. It'll appear in the Solution Explorer. With only a humble main function in our source file, we can build the solution. This creates output files in two user-selectable settings, each in a different folder, Debug and Release. Debug mode has extra information to allow debugging. This results in larger file sizes and slower programs. Release mode removes this information and makes the program ready to be released. Now let's look at the basic components of a C program. First, there are the language elements. Just like any spoken language, C consists of a series of fundamental building blocks. Each part of the code in a C program may belong to one of these elements. Keywords are predefined text that the compiler understands, things like void, int, float, if, and for. Operators perform standard operations on data. The obvious examples are mathematical operators such as add, subtract, multiply, divide, or modulo, which we'll talk more about later. But there are operators for other data types as well, not just numeric ones. Punctuators are symbols that organize the code. They serve exactly the same function as punctuation in a written language. Semicolons, for example, mark the end of a statement of code. Constants are concrete, defined values. A constant could be a number such as 12 or 34, a character like S or D, or even a text string like the word hello. Identifiers are names given by the programmers to define data and code. Basically, anytime you're making up a name to use in your code, you're creating an identifier. Variables, functions, that sort of thing. Comments are sections of text in your code that are to be ignored by the compiler and therefore will have no effect on your program. Comments can be used to explain parts of your code to other people who aren't familiar with it, or to provide additional information. Visual Studio has a range of customization options that make reading your code a fair bit easier. If you go to Tools, Options, under Environment, look for Fonts and Colors. Here you will find a list of display items, the appearance of which you can change. For these tutorials, we will have operators show up in blue and numbers show up in red instead of black. This should make reading and interpreting the code easier. Feel free to make any other adjustments you like. Changing the color theme under Environment to dark may help to reduce eye strain when coding for extended periods of time. These changes have no effect on the source code. Also, if you're making these changes on a school computer, they will be lost once you log out. You can save the changes to a file though. If you heavily customize your environment, this can be very useful. Just go to Tools, Import and Export Settings. Export will create an environment customization file you can then import whenever you're using a different computer. Next, let's talk about data. Every program processes some information. In C, data is maintained in constants and variables. The values of constants are always the same, whereas the value of variables can be changed. Variables are essentially a location in the computer's memory with a name, a value, and in C, a data type. To declare a new variable, state its type, then the identifier you wish to give it. All statements in C end with a semicolon. C supports several standard data types such as bool, char, short, int, float, and double. Each of these data types occupy different amounts of memory. The first, bool, can contain a true or false value. Char contains a single character. The latter four can contain different ranges of numbers. Int stands for integer and is used for whole numbers. The other three, float, double, and short, can be used for decimal numbers, the only difference between them being the lengths and use of decimal points. We can assign an initial value to our variable in the same statement that created it. Assigning a value to a newly created variable is called initialization. When dealing with numbers, it is sometimes necessary to specify what data type your constants are using. Whole numbers are by default integers. Numbers with a decimal are considered to be doubles. You can force constants to be floats by adding f to the end of a number. Remember, for any information used in the program, create a proper variable. This is the first golden rule of programming. Now let's get to the meat, the actual code. The code in C programs can easily be structured within functions. A function is essentially a mini program that can be executed from somewhere else in your code. You can define a function by stating its data type and name, followed by a pair of parentheses, and then the body. A function's data type refers to what type of value can be returned. If you want to write a function that returns a whole number, for instance, then the function will need to be an int. If you don't need your function to return a value, then you can set its data type to void. It should be noted that any line of code that starts with a data type is creating something new, whether it be a variable or a function. When you declare a variable in your code, it will be in one of two places. If you declare it within a function, it is called a local variable. This means that only that specific function will know about it. Other functions you create will not be able to access it. If you declare the variable outside of a function, then it is called a global variable. Global variables can be accessed by any part of the code. This leads us to the second golden rule of programming. Define variables and functions before using them. The reason for this is simple. Computers are very dumb. They need to know about any new functions or variables before they can use them. It's like a recipe. You can't follow the instructions before you know what ingredients you need. If the compiler comes across a variable or function it hasn't heard of yet, it'll complain about it. For this reason, and for readability, it is best to keep all your global variables together at the top of your code, followed by any functions you've created. For the time being, include your main function at the end of your program. A common practice, though not a required one, is to preface your global variable names with G_. In this sample code, we have a pair of global variables that are accessed from within a function. By writing gid equals 0, we are setting the value of the variable gid to 0. On the next line, we take gid, add 7 to it, then assign the result to gnum. Remember, anything on the right side of the assignment operator will be evaluated, and whatever value you end up with will be assigned to the variable on the left. When writing console applications, we can use two pre-made functions for input and output. For input, we can use scanf_s. Scanf reads the input from the keyboard and assigns that data to a variable. The _s just means that it's the safe version of the function, with memory and buffer overrun protection so the user can't enter more than the available memory size. For output, we can use printf. Alternatively, we can use cin and cout for the same purposes. For the purpose of these videos, we will be using both interchangeably, but it's recommended that you pick one and stick with it. To terminate a function, we can use the return command. In this case, the return value will be whatever the user has entered. As mentioned before, if the function does not need to return a value, then it can have the type of void. You can still use the return command to end the function, it just shouldn't be followed by anything other than a semicolon. When declaring a function, you can also include parameters. Parameters are variables that the function accepts as input. They act similarly to local variables within that function. Functions are executed when they are called inside the code. If a function requires a parameter, an appropriate value of the correct data type needs to be passed to it when it is called. It can be a constant or a variable. However, bear in mind that if you pass a variable to a function, it doesn't matter what the variable was named. When accessing the parameter from inside the function, it should be referred to by whatever name was stated for that parameter in the called function's declaration. The third golden rule of programming is this: a program is a sequence of instructions. Every program in C has one and only one function called main. Main is the starting point of your program and is the first function to run. The program execution starts from main and continues sequentially, as in one after another, until main ends. Functions will only be executed if they are called. When a function is called, the CPU will go to that function's code and continue executing instructions there until that function ends, either by running out of code or by executing a return command. The C language has only limited functionality through use of its keywords. Many operations are performed through the use of library functions, pre-written code that is provided to programmers. stdio, or Standard Input Output, is a C library that allows reading from the keyboard and writing to the screen. It is limited to text and does not handle graphics. Printf and scanf are stdio functions. cin and cout come from a different library called iostream. In order to use a library, and in keeping with golden rule number 2, we have to define those functions, or tell the compiler where and how they were defined. C and C++ libraries provide header files that include short descriptions of the functions they use. They don't contain the actual written code, just basic information. Libraries have to be included in the source files that use the library's functions. Preprocessor directives are commands to the compiler that are carried out before the code is compiled. Hash include inserts an entire header or source file into the program. Hash define gives a name or label to some text that allows the label to be used in place of that text. When the source file is compiled, the label will be replaced by the text. For instance, hash define num10 would replace the word num with 10 whenever it appears in your program. The benefit of this is that if you have a number that is referenced throughout your code, a number you might want to change later, you simply have to change the value in the hash define. This is a huge time saver if you have 100 lines of code referencing the same value. The fourth golden rule of programming is to use decision-making structures to allow conditional operations. Because a program operates in a linear and sequential fashion by default, it performs exactly the same instructions in exactly the same order each time it's run. To allow our program to be more useful, we can have it make decisions based on the data it processes. This means that it will perform an operation only if certain conditions apply. As an example, we can modify report to end when the user enters 0. The keyword we need to use is if. In parentheses, we put the condition or conditions we want to check. If the condition is met, then the following line will run. In this case, if num is equal to 0, we want a return command to execute, terminating the program. If we want to run multiple lines of code, we can use curly braces. It is important to note two things in this example. First, the if statement does not end with a semicolon. Second is the use of the double equals in the condition. Since many new programmers understandably get confused by the single equals versus the double equals, let's quickly differentiate the two. A single equals is the assignment operator. This is used when the programmer wants to set a value, for instance, when initializing a variable. The value of the variable on the left gets replaced by the total value of whatever is on the right. A double equals is the equal to operator. This is used when the programmer wants to make a comparison between two values. If you're writing an if statement, this is the operator you can use in the condition. Don't use the assignment operator because the compiler will not approve. Returning to the if statement, we can add a secondary set of instructions to run if the condition is not true by writing else. Here we want the program to determine if the user has entered an odd or even number. To do that, the statement will be if data modulo 2 equals 0. The modulo operator isn't as scary as it looks. It gives the remainder after a division. So for instance, what's 7 mod 2? Take 7, divide by 2, and whatever's left over is the answer. In this case, 1. So, if the remainder is 0, we know the number's even. Now we need to set a variable we can reference later. Here we'll create a boolean, which can be either true or false. We'll call it odd and set it to false. Now we can continue by typing else odd equals true below that to deal with the other possibility. Now in our second if statement, we print a different message depending on odd. Note that the only condition we have is just the value of odd. When there is no comparison in the condition, the program assumes it needs to check if the condition is true. It's worth bearing in mind that Golden Rule 1 was applied here. We have some data, so we created a variable for it. We have user input, and we know if it's odd or even. Always put your data in a variable. The fifth golden rule of programming is to use iterations, or loops, to perform repetitive operations. One of the main advantages of using computers is their speed when performing many operations. In most cases, these operations are similar. For example, repeating some action on each item in a list of data. Loops are a very useful tool at our disposal. Let's say we want to repeat the previous example 10 times. For this, we would use a for loop. A for loop has 3 parts. First is the creation and initialization of a new variable. This will be our counter for the loop. It is traditionally called I, but like any variable in C, you can name it whatever you like. As long as this condition is met, the loop will run. In our case, we will write I less than 10. Finally, we set the increment that will be applied to the counter at the end of every loop. I++ is simply shorthand for I equals I plus 1. Incidentally, that's where C++ got its name. There's some programmer humor for you. So we have a counter that increases by 1 every time the loop runs. Then at the start of every loop, we check to see if the loop has run fewer than 10 times. If not, we'll end the loop. Just like with if statements, we can run as many lines of code as we like by using curly braces. A second type of loop we can use is the while loop. While loops only have one part, the condition. We can modify our program to end when the user wants it to by using a while loop. We'll create a Boolean called end and initialize it to false. Then, as a condition for this loop, we'll write end is equal to false. The program needs to end when the user enters 0, so we'll just need an if statement to check if that's the case. If it is, then we'll set end to be true, and the loop will no longer repeat. But we need to make sure the remaining code doesn't get run. Because the condition is only checked at the beginning of each iteration of the loop, nothing is stopping the program from executing our code one last time. So we'll add an else statement and move our code into some curly braces. Now the code will only run if the user enters a number that is not equal to 0. The act of putting one if statement within another, or of putting loops inside other loops, is called nesting. Sometimes it can be hard to know when to use which kind of loop. The general rule of thumb is to use for loops whenever the program should know exactly how many iterations are needed, or will have some data that tells it how many times it needs to run. One example would be if the user enters a number to tell the program how many times the loop should run. You as the programmer don't know what that number is, but you know that the program will when it's run. In that case, you can use the variable containing this data in the condition of the loop. If you don't know how many iterations will be needed, then you should use a while loop. That said, this is just in general, so it's entirely possible to write something equivalent to a while loop using a for loop, and vice versa. Well, that's it for Module 1 and a review of the C programming language.